Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Kenneth S. Crane. Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay. The ionization energy of potassium is 4.34 electron volt. The electron affinity of iodine is 3.06 electron volt. Dear students, we will see that both these values will be given in one table, okay, which will be used as a helping tool. Okay, the ionization energy of potassium is 4.34 electron volt. The electron affinity of iodine is 3.06 electron volt. At what separation distance will the potassium iodide, okay, the same thing which I emphasized in my previous video, that just like sodium and chlorine and then sodium chloride, just as potassium and bromine and then potassium bromide, similarly potassium and iodine and then potassium iodide. Okay, at what separation distance will the potassium iodide molecule gain enough Coulomb energy to overcome the energy needed to form the potassium plus and iodine minus ions? Okay, dear students, here actually we have to find out R. Here U is given and value of, we know that E square over 4 pi epsilon naught is always given, is already given in table, and hence using the same formula which we applied in previous problem, we will find the value of R, and we will conclude that separation must be less than that value. If separation exceeds that value, then this possibility may occur that these ions may be formed instead of molecule. Okay, so as usual, we first come to helping tools. Helping tool number 1. Dear students, here in third row, potassium is given, its ionization energy is given as 4.34, while in fourth row in the second column, okay, this was third row first column, and now we are talking about fourth row second column. Iodine is given and its electron affinity is given as 3.06 electron volt. Okay, both these values are given in this statement. Okay, this value 4.34 potassium and 3.06 electron volt for iodine. Okay, both these values, potassium 4.34 electron volt ionization energy and iodine 3.06 electron affinity, 3.06 electron volt. Now we take its alternate version in which these values will again be repeated. Okay, this is the alternate version of tool number 1. Here we find where potassium occurs and where Dear students, here Ki potassium iodide is given. Okay, it has value 0.353 nearest neighbor separation, 0.353 nanometer. I think the purpose of this table is enough to this extent that 1 2 3 4 5 6 7 8 9 10 11 12. Okay, at row number 12 data about potassium iodide is provided, which is 0.353 nanometer nearest neighbor separation, then 0.035 repulsive range parameter nanometer. Okay, then 627.5 dissociation energy kilojoule per mole. Okay, anyhow, this table is also useful for us because in this problem we are talking about potassium iodide, and potassium iodide is included in this table. And after solving this problem we may compare our results with the data provided in this table. Okay, anyhow, now we move to tool number 2, which has also been used in previous problem, so we do not discuss it in detail, we skip for the time being. Okay, next, other version of this tool is given, and this tool has this version has also been taken previously, so we skip this. Tool number 3 is also table which has been used several times, so we also skip this table. The only result which will be used is that E square over 4 pi epsilon naught. Okay, this E square over 4 pi epsilon naught is equal to 1.440 electron volt nanometer or million electron volt femtometer. Okay, we will take this value electron volt nanometer. Okay, now we come to solution in a formal manner. Okay, we are provided with the data. The ionization energy of potassium equal to 4.34 electron volt. The electron affinity of iodine equal to 3.06 electron volt. Difference 4.34 electron volt minus 3.06 electron volt is equal to 1.28 electron volt. Okay, quite clear. In statement both these values are given. Okay, 4.34 electron volt, which is the ionization energy, and 3.06 electron volt, which is the electron affinity of iodine. Okay, and what we have done, we have taken their difference. Okay, difference has become equal to 1.28 electron volt. Now, using the same formula, same expression as in previous problem, which is basically expressing electric potential. Okay, U equal to electric constant or Coulomb constant K, which is equal to 1 over 4 pi epsilon naught Q1 Q2 over capital R, where R is separation distance. In place of Q1 Q2 we will take E elementary charge, and hence we will get E square. From here we shift capital R on other side of equality and shift U on other side of equality, and hence This implies that capital R becomes equal to 1 over 4 pi epsilon naught E square over U, and this alternatively becomes equal to 1.440 electron volt nanometer, because in tool number 3, in which a table is shown which has been used several times in our problems, in our videos, according to that tool, according to that table, value of E square over 4 pi epsilon naught is equal to 1.440 electron volt nanometer, or million electron volt into femtometer. Okay, here we are not taking million electron volt into femtometer, we are taking this. Okay, both are equivalent values. Okay, moreover, U is given. Actually, basically it is not given as it is in the statement. In the statement, ionization energy is given and electron affinity of is given. Okay, ionization energy of potassium is given and electron affinity of iodine is given, and we have taken difference of these two values in electron volt, and their difference is equal to U. Okay, and hence after simplifying we will get capital R equal to 1.125 nanometer, and this is our solution of the problem. This implies that R must be less than 1.125 nanometer. Okay, we have calculated the value of R, and we know that R must be less than this. If R exceeds this value, then there is a possibility that potassium iodide will not remain a molecule. It will be converted into ions, potassium plus and iodine negative minus. Okay, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.